So there are many different ways to separate substances, and I've got images on here, and we are going to also watch some videos and define these. Okay, so the methods we're going to investigate take advantage of differences in physical properties of the substances. So you have to have substances that have got different physical properties, and you have to be able to figure out what the different properties are, and then you can actually separate them. Depending on what those properties are, what the differences between things are, you can use lots of different techniques. So the first one is just hand separation. So this is a pretty straightforward thing. I'm just going to show us a little video about it. So this is, oh, whoops. Oh yeah, here we're just going to talk about mixtures and compounds first. Whoops, we're frozen maybe. Oh no. Here we go. Are we going to have any sound? Oh. So we've got here a physical property difference. One of these is magnetic, one of them is not. Okay. Oops. So, hand separation. So mixture types that you can use this for, mechanical mixtures, of multiple solids. A suspension, as long as there are one or more solids present. Solids, so greater than or equal to one solid. You can use all kinds of different things for this. You can use sieves, you can use magnets. If you've strained pasta with a strainer, you have used this technique. Have any of you guys seen, there's like a video circulating around right now of baby formula, and somebody's like putting a magnet over it and then iron. There's like magnet, or sorry, there's like iron filings that are coming to the surface. No? It is, yeah. So there's this video, this person has taken baby formula and they've put a magnet to it, and they're like running this magnet along it. And they're like, look, there's like shards of metal in your baby formula. So they're hand separating this mechanical mixture. And did you guys notice that when the iron was attached to the magnet, it looked like big spiky like pieces? So when they do that to the baby formula, it looks like quite scary, but it's actually a powder, and is really, it's good for you. So you need to have iron in your diet. So it's like fortified baby formula with iron, but people are using this mechanical hand separation technique and like scaring people. Like people are buying baby formula, like special ordering it from Europe and stuff. So yeah, like use chemistry for good. Okay. So when to use this? So oh sorry, description, blah blah blah. Yeah. Okay, when to use this? So you would use this when large chunks of solid are present among other solids in a liquid. And then there's just some images below this. We've got hand separation where somebody's using a sieve. Even just like using your hand to physically pick different things out of like rice, that's hand separation. So this is a very basic but useful form. Can I flip the page? Next one's going to be filtration. So I will probably use filtration in after some of our labs where we'll make solids and they'll be in a liquid. And I'll use essentially what looks like a coffee filter, but has much smaller pores to get solids that could be harmful to the environment out of whatever it is to then pour down the drain, or it maybe will go in the waste bucket. But filtration is a very common thing that we use in chemistry. So this is useful for a mechanical mixture where you've got solids in a liquid or in a gas. The description of the method here. So for separation of mixtures, it only works when the solid particles present are big enough to be seen. So smaller particles would pass through the filter paper or other strainers. So you need to have solid particles that are big enough to be seen for this to work. You can use filter paper in a funnel. And in this case, solid will stay behind. And liquid will pass through. And we will use this technique in a lab where we're isolating a solid. I think it's in our 4th unit. Okay, so when would you use this? In this case, you want to isolate a solid or a liquid. So sometimes you might want to capture the solid, sometimes you might just want the liquid, sometimes maybe you want both. And when solid particles are present in a large amount of liquid, before we flip this page, I'm just gonna put this down a little bit here. Just some terminology. If you guys see in the bottom image here, this is what a filtration setup will look like in a lab, where you've got a beaker or something you're filtering into. This is where your salt liquid is going to be captured. Filter paper, and then you'd have a funnel just on the other table there. And then you'd have a funnel here with a filter paper in it, and this is where your solid would be captured. So then at the end, you've got your residue, which is your solid, and you've got, sorry, this is in the way, and you've got your filtrate, which is what the liquid was in that thing. Okay, can I turn the page? You got it? Okay. Alrighty, evaporation. Watch a video on this. But lovely music. As you guys can see, what's happened here is there was a liquid with a solid in it, and now all of that liquid's been evaporated, and what we're left with is a solid. Can you isolate and capture the liquid in this situation? Yeah, okay. So generally you would use this if you want what the solid is. But yeah, you could capture the liquid if you had something over top of it. Okay, so evaporation. This is a solution or suspension. So this is when you've got solid or solids in a liquid. And the description of method or equipment, you evaporate or boil the solid, or sorry, the liquid away. So one of the labs that we will do, we're gonna first filter, and then after we're done filtering, we will use evaporation to get the rest of the liquid out. When you would use this, generally you use this when you want the solid. Solution or suspension. And then in the bottom image there, we have got salt water, and we are evaporating the water out of it, and we're being left with the salt. All right, distillation. I love that this guy has acetone and water, but not just nail polish remover. Okay, so it's really important when you're doing this that you have two different vaporization temperatures in your liquid. Like acetone has a much lower vaporization temperature than water, so therefore it is condensing and turning into vapor, and you can collect it. And water is not doing that at that point because it has a higher temperature requirement in order to do that. Okay, so mixture types for distillation are when you've got a solid and a liquid, or, and this is the first time we've seen this, a liquid and a liquid. Okay, so this can be used to separate solid and liquid, or liquid and liquid. But unlike evaporation, you still have both things in the end. And I did not leave much room for this. Or separate two liquids with different boiling points. And that's really the most important part, is different boiling points. So that's the physical characteristic that's different. For every method of separation, we need to have different physical characteristics. For this one, it's boiling point. And you use this when you want to keep both components and compounds. Components or compounds. And I'm going to explain this diagram here. So this is continuation of description of method and equipment. We do have this equipment, so I'll set this up for you guys on Monday so you can see it more. But here we go. So we apply heat. And then we use a thermometer, and we get to the lower boiling point. So we do not want to get to the boiling point of the thing that has a higher boiling point if it's two liquids. Vaporization occurs, so we get vaporization. Now, as we know, things when they go from a liquid to a gas form, they fill the space of the container that they're in. So what's going to happen with this vapor is all these molecules are just going to fill this whole area. And then once they get into this section with cold water, it's cooling this back down, cools vapor, and we get condensation to re-liquefy. And then we get that condensation is liquid form again, and we capture it in a beaker or an Erlenmeyer flask or whatever container we're going to catch it in. So this is hooked up to like a sink with a hose, and water goes out into the drain. And yeah, I'll set this up for us on Monday so you guys can see it in action, because it's pretty cool. It's kind of equipment intensive, but it's really neat. Okay. Does everybody have this page? Do you guys need me to go back up at all? Okay. All right. Solvent extraction. Just got a couple left here. I just want to clarify that in this demonstration, he's mixing these things together to separate them. Normally when we're separating things, like it would be you're getting something that is mixed together and you want to get them out. We're not going to like mix things and then separate them, because that's kind of pointless. Also, this looks really gross. Okay, so this is separating immiscible liquids. And if you guys look on just the next sheet of your, it shows these separating funnels. Okay. So the mixture types that you can use this for, you can use this for a solid and liquid. Solvent extraction. It's a little bit different than that. You can use this for a liquid in liquid. And you can use this for a mechanical mixture of I'm going to zoom in a little here. Mechanical mixture of solid and solid. So there's two different types of solvent extraction. For solutions, you can extract, a dissolved liquid or solid from a liquid solution. You would do this by adding another solvent, so something to dissolve your solute in, that's immiscible in the other liquid. So it's kind of a multi-step process here. So immiscible just means doesn't mix. So I think the example that they gave of oil and water is a very common example of immiscible liquids. So that other solvent, which is immiscible, doesn't mix with the original solute, the purpose of it is to dissolve the solute. So you are dissolving whatever solute you want to get out of this. And they have to have different densities because one needs to go to the bottom, right? For mechanical mixtures, you're going to do a similar thing. You're dissolving one of the solids, but leaving the other one undissolved. So some things will dissolve in certain liquids, but not others. So you're choosing a liquid that will dissolve one of your solids, but not dissolve the other. This will mean that those things, and then you add another solid, So you're adding a liquid that dissolves one solid, but leaves the other. Then add a second liquid to dissolve the second solid. And again, those liquids must be immiscible. So there's quite a few requirements for this. You need something that dissolves one solid but not the other. You need another thing that dissolves the second solid. And those two can't mix. It seems like a lot of steps, right? Immiscible. how do I spell this? Just like that. Yeah. Okay, so when to use this? Or sorry, I'll leave that for a sec. In solutions, you would use this if there are 2 or more immiscible liquids. Oh, sorry, this does have a C in it. So water and oil. Or 2 or more miscible, which is just the opposite of immiscible liquids. So water and ethanol are an example. Those 2 are miscible, they do mix. And a solvent can be added to dissolve one, but not the other. Okay, and then I'm just gonna finish this one last thing, and then we'll be done. Okay, mechanical mixtures. You would use this if one solid is preferable. You want to get one solid, and it dissolves in a particular substance. Or a particular solvent, rather. Maybe we'll do some recrystallization. Can I flip the page? Okay. Yeah, almost. Okay, so these diagrams just show that separation technique. So just kind of have a quick look at those. We can see we need to have different layers of things, distinct layers, so we can remove one from the other. So what we're going to do on Monday, you guys, is I'm going to set up a couple of these things so that we can actually see them. We're going to talk about recrystallization, and we might do a quick demo on that one. And then we are actually going to get ourselves prepared to do this last one, which is called paper column and thin layer chromatography. So we'll do a lab on this one probably on Tuesday, but we'll definitely do some demos and go through that stuff. Okay, so just make sure that you guys finish the homework from 3.3 over the weekend. Come in with any questions that you might have. You could maybe just make a note on your sheet here, like I wasn't sure about question 34 or something, and then we can go over it as a class. And you all are free to have lunch. Just remember, you guys have to be in here for the first like 10 to 15 minutes, and then you can head out after that.